Hello and welcome back to the Physics Basket. The topic that we are going to cover today is Class 9 Foundation Topic 2, and the topics are momentum, Newton's second law of motion, law of conservation of momentum, Newton's third law. So let's get started. So let us start with Newton's second law. From the Newton's first law of motion, we have already understood that some kind of an unbalanced force on the system would generate acceleration. Let's understand it further. If there are two masses of m1 and m2 being applied by forces F1 and F2, wherein mass m2 is greater than m1, right? Then the amount of force that is required to generate the acceleration on m2 will be more than the amount of force that is required to generate the acceleration on mass m1, which means that F2 is greater than F1. This simply means that the larger the mass, the larger is the amount of force required to generate the acceleration on the body. So force is directly proportional to mass. Okay. Further to it, if we see, if there are two masses, objects of same mass, m1 and m, which means that they have same mass and they are being applied by two different forces, F1 and F2, and they generate acceleration a1 and a2, wherein a2, the amount of acceleration on the second body is higher than the amount of acceleration on the first body. This means that the amount of force that is required to generate a higher acceleration would obviously be more than the amount of force that is required to generate a lesser acceleration on the body of same mass. So it again means that F is directly proportional to acceleration. So higher the acceleration required, higher is the force required. From this we can derive the force is directly proportional to the product of mass and acceleration. And if we equate it in terms of an equation, we can add a constant saying that F is equal to kma. Now if we equate it further, then if the mass of the body is 1 kg and it generates an acceleration of 1 meter per second square, then the total force required is nothing but 1 Newton. So 1 Newton is equal to 1 kg. We replace the mass by 1 kg into the acceleration of 1 meter per second square. So, and in this case, k is equated to 1. So 1 Newton is nothing but the amount of force that is required to generate an acceleration of 1 meter per second square on a body of mass 1 kg. So that is what defines Newton, which is the SI unit of force. So let us understand what is momentum. Momentum is basically the mass in motion. If a body is moving, then momentum is the measure of the overall motion of the object. So momentum can be defined as the mass of the body and the velocity of the body. For the moment, we can take as velocity as the total distance or displacement covered by the body per unit of time. For deep understanding, we will be covering the same in the further chapters. So momentum is equal to mass into velocity. Now higher the mass, the higher is the momentum of the body. Similarly, higher the velocity, higher will be the momentum of the body. Let us understand it further with some example. Say a bus which is of higher mass, capital M, is moving with the same velocity as that of a car which is having a smaller mass, small m. Right, so in this case we are seeing that the velocity is same but the masses are different, and we know that capital M is greater than small m. So as we know, momentum is the total mass in motion, nothing but the momentum for bus is equal to capital MV, whereas the momentum for the car is small mv. So obviously the momentum of the bus is higher than that of a car as it is associated with a higher mass, though they are both of them are moving with the same velocity. So P bus is greater than P car. In this case, we are using P to denote the momentum. Again, Momentum, as it is associated with the velocity, it is a vector quantity, and the direction is same as the direction of velocity of the object. So let us start with the law of conservation of momentum. If there is no unbalanced force on a system, the overall momentum of the system remains constant. Let's understand it further. Say there are two masses of mass m1 and m2. They are moving with velocities which are different velocities u1 and u2, and they collide with each other, and then they separate and move in different directions with velocity v1 and v2. So again, considering the situation wherein these two masses are moving with initial velocities of u1 and u2 with masses being m1 and m2. Now in this case, the total initial momentum of mass m1 is m1 u1, and the initial moment of mass m2 is m2 u2. So the total initial momentum of the system overall taken together will be m1 u1 plus m2 u2. Now after this collision, the bodies separate out and they start moving with velocity v1 and v2. So the total velocity, total momentum of the system after collision will be m1 v1 plus m2 u2 v2. Now, as per the law of conservation of momentum, the total momentum before collision will remain equal to the total momentum after collision. So this is what leads to this equation: m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So to define it further, for a momentum in an isolated system which is not influenced by any external force, the total momentum of the system before collision remains constant with the total momentum of the system after collision. So Newton's third law of motion. Newton's third law of motion states that every action has equal and opposite reaction, and it is always in the opposite direction to the direction of the applied force. Let's consider some examples. The body is placed on a table as shown below, and the body will have its own weight mg, which will be acting downward like this. Since it is on top of the table, table will also give a reaction force R in the opposite direction. As per the Newton's law of motion, since the body is at rest, the total reaction force on the body R will be equal to the weight of the body, or R is equal to mg. Let's take another example. This is a massless and frictionless pulley which is attached to a surface through a string, and a body is hanging on the other side of the string. The mass of the body is m, and the total weight of the body mg will be acting in the downward direction. So since the body is at rest, it will also, because of the weight of the body, it will also get a tension force or the reaction force T in the opposite direction. And as per the Newton's third law of motion, this particular tension or the reaction force will be equal to the weight of the body, and it is opposite to the direction of the weight of the body. So T equal to mg. So this brings us to the end of this topic, and the upcoming topic is motion, distance, and displacement. So till then, thank you for being here, and let's catch up in the next topic. Subscribe for further updates. Thank you.